Welcome to the innovation entitled Reduction of Pollutants in Brine Effluent Using Electrocoagulation. This work was carried out by our group members, Dr. Noorhafiza Kasmari, myself, Nooralina Yaziz, Mohammed Najmi Saruddin, and Noordia Akila Mazlan. For the introduction, brine effluent is a major byproduct of desalination and aquaculture. It contains high levels of salinity, COD, turbidity, and heavy metals like aluminum and zinc. If discharged untreated, affects aquatic life and violates discharge regulations. Electrocoagulation, or EC, is one of the most sustainable methods for wastewater treatment due to its simple setup, compact size, and ability to process large volumes of water with no chemical interaction. High salinity causes low dissolved oxygen in water, threatening aquatic life. Not only that, most conventional treatments are either too costly or need long retention times, making them impractical. Due to the high removal rate and zero added chemicals, electrocoagulation is seen as an appropriate alternative for treatment. This study supports several Sustainable Development Goals, which is SDG 6 clean water and sanitation by improving water quality and reducing pollution, SDG 12 responsible consumption and production by providing a chemical-free and cost-efficient solution, and SDG 14 life below water by preventing harmful discharges into rivers and oceans and protecting marine life. This study has two main objectives. First, to determine the characteristics of brine effluent before and after electrocoagulation treatment. Second, to evaluate the effectiveness of electrocoagulation in reducing pollutants in brine effluent. Through these objectives, the study helps address environmental risks and promotes electrocoagulation as a low-cost, sustainable treatment method. The study also helps address the environmental risks of untreated brine discharge. It promotes electrocoagulation as a low-cost, chemical-free alternative, especially for small and medium industries. The findings also can benefit industries, government, and local communities. The brine samples were collected from the Kota Baru desalination plant. Treatment was conducted in a lab-scale batch reactor using aluminum electrodes. Durations tested ranged from 30 minutes to 150 minutes to observe time-based changes in pollutant reduction. This is the workflow. Brine samples were treated using aluminum electrodes in a batch reactor and tested within durations of 30 to 150 minutes. Parameters analyzed were pH, COD, turbidity, aluminum, before and after treatment. These images show physical changes in the brine after treatment, including visible settling of particles and clearer samples. This is the data collection for the project. Each result was also tested using ANOVA, a statistical method, to confirm whether the changes were significant or not. In addition, FTIR analysis was carried out to study the chemical composition changes in the sample. This graph shows the pH levels before and after treatment. pH increased from 5.11 to 7.41, achieving near-neutral conditions. This is due to hydroxide ion generation during electrolysis. The ANOVA test confirms the difference is statistically significant, meaning electrocoagulation had a real effect on adjusting pH. For COD, there was a clear reduction after treatment, from 26 to 2 milligrams per liter, achieving a 92% reduction. This indicates strong oxidation and removal of organic content through anodic processes and flocculation. The ANOVA result was also significant, confirming that electrocoagulation effectively reduced organic matter in the brine effluent. This graph shows turbidity increased after treatment. This was due to the formation of aluminium hydroxide flocks that remained suspended. Since no post-treatment such as filtration or sedimentation was applied, these flocks remained suspended in the water, making turbidity appear higher. The ANOVA p-value is extremely low, indicating a significant change compared to the initial state. The aluminum concentration decreased from 0.38 milligrams per liter to 0.019 milligrams per liter, a 95% reduction. This removal happens because aluminium ions released from the electrode hydrolyze and form aluminum hydroxide flocks. These flocks adsorb dissolved aluminium and other pollutants, which then settle out. The ANOVA test again confirmed this change was statistically significant. This shows the strong effectiveness of electrocoagulation in removing dissolved aluminium. This FTIR spectrum shows the chemical composition and functional groups of the brine sample over time. It provides supporting evidence that pollutant removal occurred, as the functional groups associated with organic pollutants reduced after treatment. This table summarizes the removal performance after 150 minutes. pH is neutral. COD and aluminium show over 90% reduction, and all values are within DOE effluent regulation, except for turbidity, which needs further post-treatment. The novelty of this innovation, the brine effluent is treated using electrocoagulation and confirms the results using FTIR and ANOVA. This ensures that the observed pollutant reductions are not only visible, but also statistically and chemically verified. Thank you for your attention. We look forward to any questions and feedback.